Well, welcome everyone. Um, Very happy to be able to host this event for you and to give you my somewhat abbreviated talk about soil health, growing practices, and some of our overarching principles that we use as growers here. Okay, we're a small organic farm. We raise vegetables. We raise laying hens. We are expanding into perennial production in the next, well, currently and into the future. We are certified organic, but I tend to think of the principles that govern how we do things out here as being a little bit above and beyond the organic philosophy. Okay? Um, so the thing that I think is most important for us to keep in mind when we're sort of walking around and talking about the different principles that we use out here is that the soil that we grow in is a living thing. Okay? The soil is alive. Okay? You can think of it as something, if you like to think about it like this, it's helpful to think about it as perhaps a human being who has their own tissues, their own cells, their own bloodstream, but whose body is full of microbes that help us digest our food, that help us control our mental health, that help us with our muscles, our skeleton. Every aspect of the human being relies on a community of microorganisms. Is everybody okay with that? Okay. The soil is essentially the same thing. The soil is a structure of quote unquote non-living things that are enmeshed in an ecosystem of living organisms. Okay? The soil is alive. There is a whole diverse array of different kinds of microbes living within the soil. What we tend to think of when we think of soils and growing in soils are plant root systems. Okay? And plant root systems are part of that living community. They are both a provider of energy and a recipient of energy from that living system. And I'm of I come from a philosophy that says that in fact it's not really possible to extract roots from soil and soil from roots and have a living thing any longer. They are synergistic. They belong together in order for them to fully fully express themselves or reach their full potential. Okay? So with that in mind, we're always trying to consider. With that in mind, we're always trying to consider how we impact that living thing, that soil. A helpful analogy is to think of your stomach, to think of your gut. Okay, 90% of the microbes that live in your body exist in your gastrointestinal system. Okay? And their role is to not only digest food, but to help maintain a full body balance of your physiology. Okay? Everything from the chemicals that interact with your brain to the chemicals that interact with your joints. The gut is a catalyst for all that. If you impact your gut negatively, you experience all sorts of pain and discomfort that make your life miserable and make it difficult for you to reach your full potential, either over the course of a day, a week, or over your whole lifetime. Our gut is inside of our bodies, inside of our skin. A plant's gut is outside of its root system, in that living thing, that soil. Okay? All of those microbes that we have in our gut are contained within us. All of those microbes that plants are associated with, well, I shouldn't say all, but most are found outside of the root system. And they digest and cycle energy and nutrition from the soil and provide food to the plant that way. Provide energy and sustenance to those root systems. Does anyone have any questions about that? Okay, so now when we are going about our lives and we're considering or not considering, depending on how cognizant we are of this or how much we care about it, what we're putting into our bodies affects the entire system. How we interact with the soil affects the entire system. Okay? If you want to think of the soil as like a gigantic quilt that covers a bed, the size of that quilt goes over your entire property, spills into your neighbor's property, into your entire community, into your entire state, continent, goes down into the continental shelf, and connects the entire globe. So when we are interacting with soil in our gardens or on our farms, we're going to be interacting with that system that is tied into the entire planet. Okay? We're dealing with just a very, very small part of it in a very, very typically shallow area. Okay? So what we want is a simple way of interacting with that soil so that we can do what? What are we? Harvest. We're interested in growing things, right? This group? Yep. Okay. So in order to grow the plants and the plants and animals that we're interested in, we have to try and find the best way to interact with the soil. Now, there are essentially 4 elements that need to be balanced when we are managing a soil, okay? So we're talking about management now, okay? 4 things. Life needs, much life needs air to breathe, water, okay, to sustain, mineral nutrition, okay, so think, if you're eating carbohydrates or protein, fats, these sort of things. And it needs a matrix of carbon, okay, because all of us are built out of carbon structures. Okay, all of life is built out of carbon structures. Okay, so again, soil is essentially fits those needs, has those same requirements as any sort of contained organism that you can think of, like a cat or yourself or a tomato plant the soil requires those same fundamental resources. Okay? How balanced that is depends on how we interact with it. So on this handout that you've got, there are 4 basic elements that we need to balance that I just outlined. Now, if we look at those things in a balanced format, we want to have soil that has about, again, so this is like region specific a little bit, okay? So for southern New England, ideally we'd like to have between 6 and 7% organic matter in our soil. Does everybody understand what soil organic fundamentally is? Yeah. All's well?
No, we don't.
No, okay. So when I talked about those 4 basic elements, the carbon matrix, okay, the carbon resource is provided by living things that have died. The egg has a lot of minerals in it, and the banana has a lot of carbon in it. And when you take those 2 things and when they decompose, say in a compost pile, they fuse. They interact and they become a puzzle or a matrix or a labyrinth of all of their former parts become intertwined with each other. All right? Think about a big pile of leaves. You can distinguish all the individual leaves for a while, but eventually you can't. You can distinguish the bananas and the eggs that you threw in that compost pile for a while, but eventually you can't. They interact, they fuse, and they become something that we call organic matter. Yeah, so that's a great question. And let me see if I can answer it succinctly. So the lower percentage of organic matter you have, the smaller representation of microbes you have, and you have what some people call, or what you can think of as like a sleepy soil. Something that doesn't cycle nutrients very quickly, okay? When you have a higher percent of organic matter, then you can actually bump into the same problem, where you have more material that can get cycled, and you can basically tap out the microbes that are there. It kind of happens, it sort of happens both ways. You can have really high charge soils when you add too much organic matter that just burn through the material. Or you can have the opposite effect where things get, if it's like too wet, for instance, like a soil like that will get bogged down and like hold too much water and so on and so forth. But typically what soils do naturally is buffer themselves to about this range of organic matter, where it's not too high, it's not too low. When you have high organic matter, especially if you're adding compost to soils, you can get really, really high levels of soluble nutrition, which will slow down or speed up the biology. So it kind of throws things into disarray. It affects the energetics so that it's kind of like hot or cold. But its tendency is to always sort of cool down to this equilibrium. And organic matter will drop over time if you're not adding more. But the rate of it being digested changes, and you don't really want it to be super, super hot. You want it to be kind of like of an even keel.
So is the 6 to 7% like particular to this region, or is that kind of a general?
Yeah, it's 6 to 7% organic matter in Rhode Island is unusual unless you're adding compost or doing a lot of cover cropping or rotating.
I guess my question is like 6 to 7% soil organic matter, like what every person everywhere should
No.
aim for?
No, because our soils are very, very sandy, they tend to burn through soil organic matter more quickly. So our equilibrium is closer to 6 to 7%, if I can put it that way. But if you were to go to the Midwest or the South, where the soil is much more fine, is much more clay rich, you can have maintained higher soil organic matter levels at a higher equilibrium. Is that somewhat helpful? Okay. Okay, so that's soil organic matter. Any other questions like about specifically what it is? Okay. The next thing to keep in mind is that the soil is primarily, the physical part of the soil is primarily made of rock. Okay? Very, very fine rock. Okay? And the size of those rocks determines a soil's texture. Okay, so like I was just saying to Tiferet, soils in southern New England are very, very sandy typically, okay? Unless you have the benefit of being somewhere where a lot of fine material has washed into a floodplain or something like that.
So is it sandy because we're coastal?
It's sandy because our soils are young, okay? It's sandy because our soils date back only about 14,000 years to the last ice age. When the glacier receded, our soils were left behind and created at that time. So the soils just south of where the glacier stopped in like modern New Jersey tend to be much older and therefore much more broken down and so finer. Okay. All right. So sand, and if you trace the line of where the last glacier stopped and then receded, that line and above and north is indicative of where you can expect to find sandier soils. Now there's very, very large areas that were washout plains where finer material filled in valleys. Even in Rhode Island, like in Exeter, in Carolina, there's areas where there were washout plains where the sand is very, very silty and doesn't have very many rocks in it. Okay, there's some farms in Aquinic Island that have finer soils too. Okay. But places like this, we're not so lucky. It's very, very rocky, very, very sandy. Okay. So that rock is really where we get the minerals for our plant's nutrition. Okay? And the way that material is taken out of the rock is by those microbes that are existing in that soil, interacting with that mineral material and drawing it out. Okay? So they are sort of living among and within the organic matter. They're breaking down that organic matter and using that carbon as an energy source and some of the nutrition that's in the organic matter. And then they're also oxidizing the surfaces of these rocks, the sand, the silt, and the clay. And they're extracting nutrition out of that. Okay? Now, a plant root is going to be growing in that soil, and some of that nutrition that's being removed from the soil is accepted by the plant. Okay? That's just sort of the quick and dirty explanation. Okay? Now, those microbes in there, they need water and they need air just as much as the plant roots need water and need air. Okay? So when we are interacting with the soil, we need to consider these four things. Is there air? sufficient enough so that the microbes in the plant roots can breathe? Is there water so that the microbes in the plant roots can drink? Okay. Is there carbon available so that the microbes can have an energy source? Okay. And what stage is the mineral strata? How broken down is it? Are the particles very large or are they a little bit smaller? Those are the four things we need to think about. The carbon is primarily for the microbes, but the carbon from the organic matter is an energy source for microbes. But also the plants photosynthesizing and excreting carbon into the soil is also a carbon source for microbes. I was just trying not to get too complicated. Yeah, but the amount of carbon that the plant takes in and assimilates into tissue is negligible compared to how much it takes out of the air. When you are growing a plant hydroponically, the plant can produce its own carbon from the carbon dioxide. And often in hydroponic systems, from what I understand, I'm not a hydroponic expert, but I know that some greenhouses find that they actually have to pump in carbon dioxide to keep the plants sufficiently provided with photosynthate. What's missing in the soil, within that water, because they aerate it, so there's air in it, but what's missing is the mineral and the soil organic matter, and those two things both can provide nutrition. So what they put in the water is soluble nutrition. So you're replacing that wealth of soil nutrition with an artificial form. Yeah. So microbes, air, water, and the minerals in soil organic matter. Okay? When you go into your garden, okay, so say we want a balance of air and water. Let's just talk about that. Okay, we want an equal amount, say, of space in the soil full of air and water. Okay? On your sheet here, it's about 25% and 25%. Okay? When you go through with a rototiller and churn all that soil up, what are you putting into the soil? What's going into the soil? Air. Okay, what's coming out of the soil? Carbon, but for our water. Okay, water is being exposed to sunlight and the structures that are holding water. Water's sticky. It sticks to soil particles, and when those soil particles are broken apart, the water isn't able to hold on quite as well, and so it evaporates. So now you have a soil where you have a much higher amount of air and a much lower amount of water. Okay, so what else happens when we rototill the soil? All of those microbes that are in the soil, what happens to them? Some of them die. Some of them their numbers explode. But overall, the diversity goes way, way down. Okay? And diversity is what we want in all things. Right? Okay, so you want a diverse food web, you want a diverse group of microbes in there, and rototilling disturbs that so that you have microbes that do really, really well in dry, aerated environments. And then what's worse is that the carbon that's in there gets digested very, very quickly so that your soil organic matter content goes down. So now we've got three things very much out of balance. The air is too much, the water's too low, and our soil organic matter content is dropping too fast. Our microbes are no longer a diverse community. They're becoming more monocultural. Monoculture? Yeah, they're just becoming less diverse. And the minerals have been broken up and they have become soluble, and a lot of them have washed away. So our available mineral nutrition has also dropped. Okay?
Can you say again why the soil organic matter drops?
Because the amount of air that you've pumped into the soil creates a bacterial bloom, and they eat the carbon.
Can you say that again? The air that you pump into the soil? I missed the
Sure. So say in the soil, say there's all of us, and we've all got our sort of own diets and our own preferences. But say that I really, really love it when I've got a lot of air. And say the rototiller comes through and kills half of you. 3 or 4 of you don't like so much air, so you lose your appetite. But I get really excited. I start making a whole bunch of babies like me very quickly, who also like a very air-rich environment. And we're all very, very hungry all of a sudden. And we eat the carbon very, very quickly. Okay? So that's a sloppy analogy, but that's pretty much what will happen. There's an order of things that diversity brings that keeps things in equilibrium. And when that environment gets really disturbed, okay, in the macro form, think of like an earthquake or a hurricane or something comes in and makes a mess, it throws everything into disorder, and things become a lot less predictable, and they become a lot less reliable, and they become harder to put back together again. Okay? So guys, those are the 4 things that we need to think about again: the air, the water, the soil organic matter, and the minerals. And we just affected all 4 of them with the rototiller. Okay? What about if I go out with a hose and I just water my garden until my garden is a puddle? How much air is in that water now? How much air is in that soil now? Right. Very, very little. Very, very little. Okay? Now again, think of us as the microbe community. Maybe you're a great swimmer. Maybe you can breathe underwater. She's got her scuba gear or something, right? Or a snorkel. But the rest of us, we're going to drown. Or at best, we're going to go dormant. Okay? Now, those of you who can swim underwater or breathe underwater, you have a special skill, and that is that you can ferment and change the soil chemistry. Okay? So you're going to start changing everything, and you're going to start bringing that soil organic matter content down again, quickly. So just by overwatering, we've removed the air from the soil. We've changed the microbe population again, so it's less diverse. And our mineral and soil organic matter is starting to break down in ways that are not good. Have you ever gone out into the garden after a long, long, heavy rain or like a really wet spring and smelled the smell of ammonia or manure or something like that? Really, really wet soil burns off nutrition, turns it into gas, and it off gases. Okay? Too much water, too much disturbance with the rototiller. Okay? Now imagine what happens if you take a bucket of fertilizer. Okay, fertilizers are salts. Fertilizers are salts. Salts. Okay? Many, many, many of them are salts. Imagine if you go out and just dump a whole bunch of salt on your soil and then mix it in with a rake. Okay? How does that affect the water content? brings it down. Salts absorb water, right? Okay. How are they going to affect the microbes? They're going to dry out the soil. Some of these salts can kill microbes. So again, here's our little group of diverse microbes. If some of them can't tolerate salts, they'll die, or they'll go dormant. So that is going to leave a group of microbes that are going to be doing maybe half the work, or a quarter of the work, or less than a quarter of the work that needs to be done. Okay? When you have salts in soils, the water that they absorb can sometimes break them down, often will break them down, and that nutrition becomes soluble and will flow out of the soil. All right? So again, we've done something, we've interacted with the soil, and it's thrown it out of balance. Is everybody getting the point of what I'm trying to describe here in painful detail? Any questions so far? Do you want to go look at the fields and talk about how we've sort of wrestled with this information ourselves and what we do out here? Okay.
Because now I'm like, how do you grow?
Okay, so we grow a lot of annual vegetables, okay, on about 5 acres of land. All of our land has been converted to raised beds, okay? So this field and all my other fields were loosened up with heavy equipment, and then we went through and we shaped these beds. Can everybody see the distinct little mounds? Okay. Since we've made these mounds, we don't disturb them with any sort of rough equipment. We don't do anything really aggressive with them. We don't use rototillers. We don't use plows. We don't use rippers. We don't use any of those big pieces of heavy equipment that most vegetable farmers use. But let's just think about this in terms of those 4 elements. Okay, so first of all, water. We have furrows on the side here so that when we have a lot of rain, the water can settle in the furrows and go down naturally. These beds do get wet, in particular in the spring, but once we get through the early spring, these beds really, really do not get ever too wet, okay, or very, very rarely, okay, all right? The air is maintained because not only is it hard to overwater these beds, but also there's not a lot of impacting the beds. There's not a lot of walking on them. There's not a lot of equipment pushing and pressing down. So the soil has a nice balance of air and water. Okay, this is what farmers call tilth. It's got a nice tilth. Okay, so that you can stick your fingers in there and you don't ever really hit a hard pan. Okay? All right? So it's a structural thing. Okay, they've got good structure. They don't wash away unless we have like a real downpour. We don't have water overcoming the beds. And they just sort of stay like this year after year after year. So what we've done is, since we've shaped these beds, we have applied compost. We've applied compost. We do cover cropping, so we grow plants here that are not for harvest, but just for maintaining soil health. The only the fertilizers that we add to this are not salts, but they're what they call organic fertilizers. They're made from, they're sort of like a rough fertilizer made from things that used to be alive. So you can buy pulverized fish meal or alfalfa meal, soybean meal, blood meal, these kind of things. We typically use alfalfa meal in these beds, but the reason we put it down is not so much to provide the plant with a bunch of nutrition, but it's to stimulate the microbe community, okay, and get them back to work, get them proliferating, and then as those plant roots grow, those are the places, those are the areas where microbes really, really come into their own, okay, because they are linked ecologically. All right? Any questions about that? You're not fertilizing the plant, you're fertilizing the soil. And remember, the soil is alive, so it's hungry. Yeah. The soil is almost always hungry. It's very difficult to provide everything that would make the soil optimally full. Okay? So it's always a little bit hungry. Very dry this summer, right? Okay, okay. People were losing crops all over the place. There were a lot of problems. Because of our soil structure, because this soil hasn't been disturbed in any kind of aggressive way, because it has a good balance of organic matter, and because it has those pathways that help hold water and air in balance, these beds never dried out during the drought. So for instance, like that eggplant there, which has now been like knocked down by the cold weather, that never was irrigated. It was never irrigated, never watered. Okay? It was very...
We're talking about the last row?
Yes, yes.
La última.
Yeah. That was a very, very productive crop.
Esa fue una cosecha bien.
La estructura que hay en la tierra, ¿cómo lo han hecho?
Okay? So, now, we do irrigate, we do use water. For these things like the carrots here, they're irrigated once or twice in July. We would put overhead on this and water it in for maybe about an hour and a half. And for the carrots, it would have been twice. For other things like that lettuce, for instance, or this fennel that's been harvested, or that lettuce over there, or the leeks, things that we transplant, water that in at least once so that it has time to grab without becoming stressed. Okay? Is this making sense?
Yeah.
Okay. Yeah, we do. So the peppers and tomatoes this year were impacted by the drought because they're so thirsty, especially when they're in fruit. It was hard to keep them watered. But we still had a ton of tomatoes, a decent amount of peppers. So we really experienced very, very little crop loss during the drought while using about the same amount of water that we normally would. Okay? So, every time I interact with these beds, I think to myself, how is this going to affect the air? How is this going to affect the water holding capacity? Not just the water that's in there, but its ability to maintain its water. You know? Okay. Not just the air that's in the soil at that moment, but the pathways where air can reside. Okay? Soil is a labyrinth, but it doesn't start off a labyrinth. It starts off as an often very, very compacted, compressed pile of minerals with not very much air in it, not very much water in it, or too much water in it, and a very undiverse community of microbes. Remember how I said this area used to be covered by a glacier and then it receded? What was left behind? No plant life, just very, very little organic matter, just minerals, just often bare rocks or washed out rocks. Okay? If you take a whole bunch of soil without any plants in it and stamp on it, push on it with a shovel or just stamp on it with your foot, you'll push out the air, you'll push out the water, and you'll kill most of the microbes involved. If you think about it in this kind of metaphor, it's like taking a puzzle of all these different connections and just breaking it all apart. Okay? Or taking an ant colony and squashing it so that all of the chambers, all of that engineering is ruined. Okay? Or taking a house and flattening it. Okay? Life moves back in and reorganizes that. It reintroduces those pathways. Okay? Microbes come in and they are many of them are engineering pathways. They're engineering structure. They're bringing soil organic matter and minerals together into what we call aggregates. So there's this diverse engineering project that's going on in the soil over time. And as it progresses, it can get more and more diverse, okay, more and more complicated. And those complicated pathways provide more surface area, more channeling for more water and for more air to find a home. And where there's water and air and soil, there are microbes, because at every possible place, the soil is alive. Okay, so this field is where we grew our winter squash, our watermelons, and our potatoes this year, okay? When all of that crop was harvested, we came through and we used a very, very light rake that's tractor mounted. I'll show this to you before you leave today, because I'll show you how we actually prep the beds and stuff like that. We raked the material off that was in the center of the beds. We pulled the mulch over to the side so that it could degrade in the furrows. We raked the soil smooth, and then we seeded this blend of cover crops in here. It's just a blend of legumes and grasses. So once I cut those crops out and remove them from the soil, what is missing in the soil that's so important? Root systems, living root systems, okay? When I take a winter squash plant and cut it at ground level, those roots die, okay? All the microbes that were living on that root system, their whole job description changes at that point, okay? So other microbes start to dominate in the soil when it's time to break down plant root matter, okay, and convert it into soil organic matter. And that's great. We want those microbes in there, of course. We want degradation to happen quickly. But we want to maintain that population of microbes that help plants grow, okay? Where their job, they're the digestive system of the plant in the soil. We want those microbes in the soil interacting with the soil. And we want as diverse an array as possible. So the way to have as diverse array of microbes in the soil is to have as diverse array of plants in the soil. Okay. At least in this stage of succession. This is different than like forest ecology, okay? But But what we're trying to do right now is sort of mimic like a meadow or a prairie. Okay? So what you see here is grasses and legumes and some weeds, which is fine. And to Ferret's question about the types of microbes, so on your handout there's a little list of them. Okay? Right here.
Oh, that organic matter is the same thing as
Organic matter is
we're talking about.
so you can think of organic matter as almost like a condominium where microbes live,
Okay.
but they can't live there without the grocery store,
Pero no pueden vivir.
and they can't live there without whatever, the fire department. They can't live there without all the utilities. And the utilities come from the plant
Las utilidades son la planta
and from the minerals in the soil.
y los minerales en la tierra.
Okay, because remember the soil is about 44 to 43% mineral,
El suelo es
rock.
44-43% mineral.
What you recognize when you feel soil is often the rocky texture, the sandy texture.
Como le tocas,
But when you get a organic matter up around as high as it is on our farm, it starts to feel like compost or like humus. Okay, but you can still feel that grit,
it's more like
like compost.
como
Yeah.
compost. Lo pueden tocar bien.
Okay, so in this soil right here, there are some plant roots,
Habla que una raíces de planta,
but not a lot.
pero no mucho.
So you'd expect the amount of microbes in this handful of soil
Micros
to be relatively low
ser relativamente bajo
and relatively less diverse.
y relativamente menos diverso.
But if I pull this up,
Pero si yo paro esto,
okay, you see this worm? That's a soil engineer. You see all this soil sticking to this clump of roots? The closer you get to these root systems, remember, the more diverse and the more abundant the microbes are going to be. Okay? So if you were to look at this under a microscope, you'd be able to see fungi, you'd be able to see bacteria, just diverse, many species of different kinds of bacteria. You'd be able to see predators like amoeba and flagellates and ciliates. Okay, so these are animals, single-celled animals that are eating microbes and fungi. You'd be able to see nematodes, okay, and you'd be able to see, to some extent, more diverse critters like tardigrades and rotifers, and then insects and other things that are eating those guys. Okay, so you have a food chain or a food web happening around the root system. The root system is critical because it's providing the main flow of energy to the soil. The main flow of carbon is coming from these plant roots. That's why there's so much activity around them. Okay? And so as these roots grow into this soil, and by the spring, this stuff is going to be about this tall, and by June, it's going to be about this tall. Now, the root growth is about equivalent under the soil, so you can imagine how diverse and how abundant the microbes are under the soil. They're able to interact with soil that's much deeper than most of the crops we grow and cover crops that are so young like this. Okay? Now, what a lot of these plants, these younger plants can do, or these earlier succession plants like grasses and legumes, they can actually help break up some of that hard pan. okay? If you come out to a field that's tilled for decades and then is abandoned, that soil settles and becomes very, very firm. And if you plant a tree in that soil, that tree is going to have an extremely shallow root system. But if you start with growing like a lush array of grasses and legumes, that soil will have time to break up and that compaction layer will get more and more broken down deep. Okay, that's a natural succession that happens in nature. Okay, plants like this prep the ground for the forest plants that come after. That's why when you till your garden, you don't get, birch trees growing up out of it. You have a very, very narrow range of weeds that grow in your garden. They're not diverse places, right? The weeds in your garden are the same as the weeds in your garden, are the same as the weeds in your garden, and my garden, and so on and so forth, right? More or less, Okay, you're not suddenly having sumac grow, you're not having birch trees grow out, you're not having goldenrod, you're not having milkweed. Those plants come later, once the soil has been has evolved. Okay, so this is where a lot of diversity comes in. Okay, just having a diverse array of plants. And now when this grows up, I have to grow crops in here, all right? So I can't just have a beautiful tall prairie in my farm. I need to actually do something productive with it. So now it comes back to that question of interacting with the soil again. What am I going to do to it to try and maintain that balance, okay? I've just spent all this time and money growing this diverse group of cover crops, building up this diverse group of microbes. I've done my due diligence making sure that these beds have good air and good water holding capacity, okay? Good infiltration, water goes down, doesn't just puddle up, okay? So now if I come through here with a rototiller, what's going to happen to all that work I've done? Do you see that the balance is ruined? You see it. All the work I did, because I don't understand. I don't understand that once I till it, the soil settles, the air goes out, the water can pool up, no place to go. It doesn't infiltrate, it sits. What doesn't evaporate? Okay, if you till a soil and then water the heck out of it, which direction does the water go? Does it go down? No, it goes to the side, right? It takes forever to water a tilled soil, doesn't it? You gotta water it and water it and water it and wait. You gotta push the water down. Not so here. You water this, the water goes down, because that's the environment that the soil life require if they're going to be growing and expanding into this matrix, this basically infinite amount of area that they can move into. So you see the balance. So we have the raised. So we have the raised beds. Okay. Well, first we have to understand. We got to understand it. Okay. So this is going to grow up. Now I'm going to go show you the tools we use. Okay. Yep. Okay. So again, picture this in June when it's like as tall as us. Okay. So what do we do? How do we deal with this? How do we deal with these fields without reverting them back to and knocking them out of balance? So what we do is we take a mower. Okay, so you see those tires on that spreader right there? Those are set to straddle the beds, so they roll into the aisleways. All those furrows match my tractor tires. So all of our tractors can go into the field with the bed untouched between the tires, between the axles. Okay? So we drive through, I lower down a mower with a wheel on the back, and chop, 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 chop. I chop all of that material down. Okay? But it's still alive. Okay?
For how long though, John?
So then we take, I'm sorry I don't have a piece right here handy, but we have these large pieces of material right there. You see them? See that black material? We open that up and we walk it out over top, and then we pin it down with sandbags. Each piece is big enough to cover 5 beds. Okay?
You cover the bed.
We do. That material is woven so that water can penetrate. Okay? It's very important for air and water to be able to breathe. It's very important for that material not to suffocate the soil and not to keep the water out. Okay? So it's perforated landscape fabric. So over the course of several weeks, without any sunlight, that plant mat material is going to die.
What's gonna die?
The plant material, the mowed plants, because they're still alive under there, they're just mowed. If I just mow them and leave them, they're going to grow back. Okay? Okay? So we kill them with this material. Then we peel the material off. Okay? Now most of what we plant here is transplanted. Okay? So we grow in pots in the greenhouse, and then we go out and we use a machine like this. But before we use that, come on over here, everybody. Come on over, guys. Okay, so there's going to be some residue left over after we pull that tarp over. So we'll go through with leaf rakes. So if there's any mulch or if there's any dead mowed material still there, we'll rake it off. But the soil is going to be a little bit uneven. Okay, and there's still going to be tufts of like stuff in there. So we'll go through, and this is basically like a garden rake, okay? But it swivels when it moves, so it penetrates the soil about 1 inch and just catches any of the other stuff that's left behind and smooths out that top inch or so. But it's not like you're tilling it. If you stuck your finger in there below that top inch, it would be just as loose as that top inch. And you can really wiggle your way down there. Some places you can wiggle your way down like almost up to your elbow. Okay? You can just kind of whoa, lose yourself in there, which is pretty exciting because that is space where roots can grow easily and efficiently and enthusiastically. That's if a plant can be happy, that's the thing they're looking for, a place where they can root and root and root. Okay? And so, but still, we need a place to plant our plugs, right? So in front of the tines, I have these shanks, okay? So you'll see that there's 3 shanks there. They rip the soil in a narrow little furrow. It's about 2 inches wide and can be about 2 to 3 inches deep, okay? So now we've got a smooth bed with these furrows of soft soil cut into them. All right? and then we can go in behind that and plant.
Oh.
So there's a spectrum. So there is a spectrum.
Oh.
And you don't need to do this. On a commercial scale like we are, to be able to pop plugs in the ground quickly is very important. So there's a little bit of a trade-off. Okay, so what this machine behind you, that's a transplanter. 2 people sit on the back, and those dibbles, yes, yes, that we use to transplant like the majority of our crops. Okay, now those dibbles need a soft soil to push into. Okay, if they can't impact the soil and push through, then we can't put a plug in there and expect it to do well. Okay, so we have to soften up that ground a little bit, but there are those areas in between the furrows that have not been disturbed, and this disturbance is very minimal. To answer your question, for one thing, it's unidirectional. Okay, it's just pushing the soil apart basically. Okay, instead of a tiller, which is inverting. Okay. Okay. Any microbes that are dormant, any microbes that are dormant in that undisturbed soil are going to repopulate the disturbed furrows quickly. Okay, we have a lot of success with this. This is like our best, really, this is so far the best system I've come up with, is using this out of necessity for being efficient. This thing facilitates that, and the productivity of the plant is not impacted by the little bit of disturbance. I can show you what heavy equipment is. Let's go take a look. Let's take a look. Let me show you what we used to use. This thing drops compost right on our beds. The wheels straddle the bed, so they're in the furrows, so there's no heavy weight on the soil bed itself, on the planting top.
They go by the same size of wheels.
Correct. They match the furrows. Yep.
And all the compost is generated on your farm?
No, some of it is, some of it's bought in.
What's your percentage?
Well, we didn't spread a whole lot. Last fall it was all our stuff. This fall it's going to be all our stuff. But in the past we bought in a lot.
So you spread only in the fall? Is that the time you do it?
Typically, yeah. Typically, yeah. And it's been tough right now because it's been so wet.
Mm-hmm.
Yeah, can't get out quite yet. So that's what we use. But let me show you what really like heavy equipment looks like. Guys, this is heavy equipment. You see these tines?
Does that also move back and forth, or is it just like monodirectional?
That's monodirectional. But then what you do after you chisel plow is you follow with harrows like this. And that flips the soil and pulverizes it. It's like just a step below rototilling for disturbance. These are heavy. All this stuff is very, very heavy.
So how long did it take? Like how long did you farm with that before you started switching over?
Up until the fall of 2018.
Oh really?
I'm sorry, 2017.
Wow.
Yeah, in
Very recent, relative to how long you've been farming.
We did different things with no-till. I mean, we've been experimenting with it since 2014, but there was always like, the heavy equipment was always in the rotation somewhere. We would sort of like have these periods
Do it
of like,
minimally, or
yeah, exactly. But the goal was always to remove it, you know, and we finally did that.
But do you think it's because you used it that you used it for so long that you were able to then use this? Like if you came, let's say you like got to your farm
You
when
need
you
heavy
got
equipment
it,
at
like,
first.
Yeah,
But
like 20 years ago or whatever.
You only need it for
couldn't
one
start with
season.
that. Oh, okay.
You only need it for one season,
Yeah.
maybe two, if depending on how well your prep goes and how high your organic matter is. Yeah, to build the beds, you need to have some organic matter to make them stick.
Can the same method be like scaled down to something smaller and instead
Absolutely.
of like tilling, you're
Absolutely.
kind of covering and then breaking off
Absolutely.
and then, you know, okay.
All you need is a shovel to make one of these beds.
Yeah.
Yep, and a digging fork to aerate it first.
Mhm.
So what we do is, so let me just check in with you to make sure that we're talking about what you want to talk about. I could talk about how we go about making the beds. I could talk more about how we interact with the beds, how we grow stuff, which is kind of what I would like to do. But, or I could just answer any of the questions that you guys have. But I want to just make sure that people are, that we're talking about what people want to hear about.
About 5:40 right now.
Okay. So go to about 6. Is that the? Okay.
I personally want to know how you make the bed.
How we made them. So we made them with a lot of heavy equipment because there's so much space to deal with.
Yeah.
Okay? But again, you just need to go back to your 4 principles. Okay? And when you're building soil, the things that you can control directly are making sure the soil is aerated, okay? Making sure that you're adding soil organic matter, and making sure that there are plant roots in it as often as possible, okay? So what you can do, like we went through with the chisel plow, which is that thing, okay? But that's no different than a digging fork.
Yeah.
It just aerates soil
Yeah.
for a brief amount of time until that soil settles, okay? Nothing will compact your soil faster than if it's tilled and it's raining, okay? Just gravity alone helps it sink. That's one of the reasons why the raised bed forms like kind of an arch, which is structurally sound, okay? So, so you can use a digging fork, boom, 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 boom. And then you can break that up a little bit with like a hoe or a rake or something, just so that it's a little bit more workable, okay? And that's what we would do with like a harrow. We would pulverize the soil up with a harrow. And then we would go through with that machine there, and that would shape the bed for us, okay? But the harrow is no different than really a hoe in a small scale. And that bed shaper is really no different than a shovel. Well, this can be scaled up or down. Yep, you don't need, and that rake is literally no different than a. You can actually get rakes that have those those same tines on them, but a leaf rake is really just as good in a small area. So there is one thing I just want to mention that I've found really, really important, is that when you're putting plants out into the soil, do you remember how I was saying that the soil's always hungry? The soil is also kind of, it's politically tumultuous.
What does that mean?
Like there's always a lot of upheaval.
What does that mean?
Like there's always a lot of fighting.
Oh, okay. Él dice que el suelo también hay como mucha pelea, mucho patronaje.
There's always, it's nature, so it's not,
That is not
it's not predictable and clean, okay? It's often aggressive and dirty. And you can't always expect the microbes to be in the perfect situation that might benefit your plants. So what we do is we do something called inoculation. So any of the plants that are going out into our fields, in particular the ones that are being transplanted, we make a compost extract, which is basically like a liquid fertilizer made from compost, in particular made from worm compost that we make here. Okay, so worm compost has the benefit of being very diverse in microbes. And when we make a liquid extract from that compost, we can then inoculate our trays by dipping them in that stuff.
So is
Like
it,
very, like just, like very deep or just.
We have shallow tubs
Mhm.
and we have trays, and we just put the trays in the tubs and let them soak it in and take them out, shake them off, and then they go out into the field.
like compost tea essentially, but with specifically vermicompost?
Yes, and not exactly compost tea because it's not being aerated. It's a little bit more fast and dirty. Yep. Okay, so that to me is very, very important because we're essentially putting out the microbe community that would be ideal, theoretically ideal, into a soil that is harder to engineer on a large scale. Does that make sense? Okay. Okay, and we do well with it. So, so like, for instance, this broccoli. This broccoli still has a couple weeks to grow. It was planted in this way that I described. All this broccoli was planted using the systems that we described. Okay. So the soil wasn't disturbed. Yeah, some of it's a little small, but. Okay. Now the important thing to mention is that this didn't get any fertilizer. Okay? These fields got a little bit of alfalfa meal in the spring to try and again get things going. But since then, we've tried to just keep plant roots in the soil and keeping the system going. Would you guys like to go in the barn and just see the crops that we've grown? Because they're all out on display right now, and that might be a good place to wrap up. So this stuff, I'm just picking out the best stuff to show you. Of course, there's always the little carrots in there. But this stuff was grown without any additional fertilizers. So just some compost that was put down the previous fall. Hey, come on in. And a little bit of that alfalfa meal as a stimulant. And then the inoculant when the stuff is planted. Okay?
I want to remember to buy things what I